Bună seara! Vă mulțumesc că ați venit în această seară. Avem în cadrul celei de-a 11-a ediție a Bucharest Science Festival, am intrat în al doilea deceniu de existență a festivalului. Avem o dezbatere despre cum putem să detectăm metanul privind la Pământ de sus din spațiul cosmic. Acum s-ar putea să vă întrebați, de ce metan, de ce trebuie să-l detectăm, de ce să ne uităm din spațiul cosmic? S-ar fi cel puțin 3 întrebări. Nu o să intru acum în detalii. Invitații noștri specializați tocmai în detectarea metanului de sus, de deasupra atmosferei, o să vă poată povesti mult mai bine decât pot să o fac eu. Dar o să vă dau doar câteva, fragmente de informații. În primul rând, de ce metanul? Metanul este un gaz cu foarte mare efect de seră. Efectul de seră al metanului este mult mai mare decât efectul de seră al dioxidului de carbon. De obicei discutăm doar despre dioxidul de carbon. Dar pe lângă el mai sunt multe alte gaze cu efect de seră important. Unul dintre ele este metanul. De unde vine metanul? Din foarte multe surse. Începând cu sursele care țin de biologia organismelor de pe Pământ. Mă refer la fermentația microbiană, fie că această fermentație microbiană se întâmplă pe fundul unui lac sau în nămolul de pe din canalele de scurgere sau în intestinele noastre sau ale vacilor. Metanul mai poate să vină și din surse fosile. Cu toții știm foarte bine cât gaz folosim pentru încălzire și pentru generarea de curent electric. Instalațiile de transport ale gazului, instalațiile de extracție ale gazului, instalațiile de stocare ale gazului nu sunt perfecte și ele au pierderi. Pierderi care se traduc evident odată în pierderi economice, pentru că acel gaz care se pierde în atmosferă nu mai este vândut, nu mai poate să fie folosit pentru încălzit, pentru generare de energie, dar are și consecințe legate de creșterea nivelului general de gaze cu efect de seră din atmosferă. Și atunci trebuie să evaluăm această emisie, această sursă de gaze cu efect de seră. Putem să o evaluăm în multe feluri. Putem să o evaluăm și la nivelul solului, evident. Putem să trimitem echipe la sonde, echipe de-a lungul liniilor de transport, echipate cu aparate prin care se pot face măsurători. Dar este complicat, este scump, uneori poți să nu ai acces în zonele de interes. Și atunci vine o soluție naturală. De ce nu ne uităm de sus, de deasupra atmosferei, la ce se întâmplă pe suprafața Pământului în atmosfera joasă? Acest lucru pot să-l facă sateliții de observare a Pământului. Evident, lucrurile nu sunt nici pe departe foarte simple, pentru că, repet, sursele de metan sunt multiple, trebuie să poți să faci deosebire între o sursă și alta, trebuie să poți să evaluezi exact zona de pe teren de unde vine emisia de metan, trebuie să poți să faci măsurători vis-a-vis de concentrația acestuia în atmosferă și așa mai departe. Din nou, invitații noștri vor putea să vă răspundă la aceste întrebări. Dar una peste alta, ideea principală este că metanul este un gaz cu efect de seră important și trebuie să putem să evaluăm concentrația lui și modul în care aceasta evoluează de-a lungul timpului în atmosferă. Acum, de ce trebuie să facem chestia asta? Foarte simplu. Știm cu toții de încălzirea globală, sau mai precis de schimbarea globală a climei. Este simplu să vedem efectele acestui fenomen când ne gândim că în București, acum 40 de ani, iarna, timp de câteva luni, aveai zăpadă în București. Acum, în cel mai fericit caz, ai zăpadă o zi sau două și de obicei zăpada aia nu prea se depune, doar ninge așa un pic. Vedem direct efectele acestei încălziri globale. Încălzire globală care poate să pună multe probleme pe termen lung. Încălzire globală care trebuie gestionată. Nu trebuie să cădem în nicio extremă. Nu trebuie să ne ducem nici în zona în care să negăm această evidentă încălzire a climei, datorată activităților umane, un lucru pe care trebuie să-l subliniem mereu. Pe de altă parte, nici nu trebuie să dramatizăm această situație. Chiar și dacă temperatura va crește cu 3 grade, cu 4 grade, omenirea va continua să supraviețuiască. Ne descurcăm, putem să ne descurcăm, avem tehnologia necesară să facem acest lucru. Dar, există un mare dar. Întrebarea este cu ce costuri? Pentru că, de fapt, despre asta este vorba. Este vorba de cum putem să optimizăm costurile în viitor ale acestei încălziri globale. Pentru că, dincolo de partea de știință, vine partea de decizie, care nu mai ține de știință, ține de politică, ține de modul în care societatea se decide să răspundă unor probleme care o așteaptă. Iar în timp ce în zona de știință lucrurile sunt relativ clare, în zona de decizie nu e nici pe departe clar care ar trebui să fie căile de urmat. Să vă dau un exemplu simplu. În realitate sunt mult mai multe, poteci care ne așteaptă în viitor și pe care trebuie să le evaluăm ca să știm pe care să ne ducem. Dar o să vă dau un exemplu simplu. Putem, pe de o parte, să încercăm să oprim încălzirea globală cu orice preț. Am putea să facem acest lucru. Dar acest lucru ar însemna să distrugem practic industria actuală, să trăim în frig, să suferim de foamete. Dar am putea să rămânem la o temperatură moderată. Sau invers. Am putea să lăsăm lucrurile să meargă așa cum sunt în momentul de față, să ardem combustibil fosil la greu, să ne bucurăm de acea energie ieftină, dar în același timp vom avea de acoperit niște costuri pe viitor, costuri legate de ridicarea nivelului mării. E suficient să ne gândim ce ar însemna o creștere cu jumătate de metru sau cu 1 metru a nivelului mării. Foarte multe orașe mari, orașe importante, sunt situate jos, pe coastă. Bună parte din zonele dezvoltate în momentul de față, ocupate de milioane și milioane de oameni, vor fi inundate. Ce înseamnă costul strămutării acestor oameni? Putem să o facem. Repet, nu ne împiedică nimic din punct de vedere tehnologic, nu ne împiedică nimic din punct de vedere fundamental. Putem să o facem, dar ne costă. Care este costul mai mare? Să încercăm să moderăm creșterea de temperatură sau să încercăm să acoperim pierderile provocate de încălzirea globală? Se pot face simulări. Putem să vedem peste 10 ani, peste 20 de ani, peste 100 de ani, cam la ce uragane, la ce inundații, la ce incendii, la ce inundații putem să ne așteptăm. Putem să evaluăm costurile asociate. Evident, există o marjă suficient de mare de eroare, dar putem să facem aceste calcule. Iar aceste calcule, rezultatul acestor calcule trebuie comparat și se face frecvent această comparație cu costurile economice date de eliminarea combustibililor fosili. Deci este foarte important să știm care ne sunt opțiunile, ca după aceea să putem noi, ca societate, să decidem ce drum vrem să urmăm. Evident că cea mai simplă reducere de costuri, de obicei, este nu atunci când schimbi radical modul de lucru, modul de funcționare, ci atunci când încerci să faci economii acoperind acele zone în care apar niște ineficiențe vădite. Și, din nou, invitații noștri vor aborda acest subiect. De ce este important în contextul pe care l-am discutat până acum? Pentru că, de exemplu, o bună parte din metanul care se emite în atmosferă, repet, un gaz cu foarte mare efect de seră, o bună parte din acest metan provine din acele pierderi despre care am povestit mai înainte, care pot să fie gestionate prin repararea rețelelor, repararea conexiunilor dintre ele, printr-o proiectare inteligentă. Evident, și chestia asta are niște costuri. Dar în același timp, îți reduci costurile pe viitor provocate de încălzirea globală și în același timp poate chiar obții o eficiență pe termen scurt prin faptul că acel gaz pe care tu îl produci, pe care ai putea să-l vinzi unui consumator, nu-l mai pierzi în atmosferă. Din nou se pune problema, ok, să zicem că vreau să iau o astfel de măsură, dar unde trebuie să încep mai întâi? Unde sunt cele mai mari pierderi? Ca să știu asta, trebuie să fac măsură 2 și ne întoarcem din nou de unde am plecat, de la necesitatea de a evalua unde sunt principalii emițători de metan, care este sursa lor, ca mai apoi să putem să vedem ce putem să facem vis-a-vis de ei. Cred că am vorbit destul, nu cred că ați venit ca să mă ascultați pe mine, ci pe invitații mei. O să o las pe Corina să continue. Vă mulțumesc încă o dată pentru prezență, sper că veți pune multe întrebări, aveți niște oameni super competenți aici, cărora puteți să le adresați întrebările și veți obține, vă garantez, răspunsuri interesante. Încă o dată, vă mulțumesc!
Bun, acum că introducerea a fost făcută aproape că nici nu mai știu ce să mai vorbim dacă Toma a spus aproape tot ce trebuia spus. Vreau doar să-l invit pe Mihai Stoica aici, foarte scurt acum și poate la sfârșit mai intervii. Mihai Stoica este director executiv în Asociația 2 Celsius, este partener în organizarea acestei discuții și vreau să ne spună Mihai, mai mult decât ne-a spus Toma deja, de ce discutăm despre tema aceasta și de ce acești invitați aici. Mihai, te rog.
De ce 2 Celsius?
Și mă rog, de ce 2 Celsius?
Ok, sărim peste partea cu 2 Celsius.
Da.
Salutare. O să fiu foarte scurt. Metanul e unul dintre gazele cu efect de seră care e foarte, foarte important, pentru că este mult mai puternic decât dioxidul de carbon. Și este foarte important să reducem pe el întâi, ca să reușim să stăvilim cumva schimbările climatice și încălzirea globală. Deci avem oportunitatea, în deceniul ăsta avem foarte puțin timp la dispoziție și de asta sunt foarte importante aceste tehnologii și inovația care se întâmplă și cercetarea care se întâmplă în zilele noastre. Este foarte important să ne mișcăm foarte repede și din perspectiva, sigur, a cercetării, dar cercetarea se întâmplă, dar din perspectiva politicilor. Politicile nu se fac fără cercetare. Deci până în 2030 noi trebuie să reducem o bună parte din emisiile de metan ca să avem șansa să ne atingem țintele climatice și să trăim în continuare pe o planetă cât de cât trăibilă. Atât am avut de spus.
Și de ce invitații de aici? Eu o să-i prezint, dar spune tu mai mult decât pot eu să spun. Pentru că tu îi cunoști foarte bine.
Ok, am zis să facem un mix foarte interesant. Deci, pe de-o parte, e prima oară când un ONG lansează un satelit în spațiu, ceea ce e un eveniment în sine și o avem aici pe Alba Lorente, care ne va povesti puțin mai mult despre MetanSat. ONG-ul se numește Environmental Defense Fund.
Satelitul pe care îl vedeți aici pe ecran.
Așa. Îl avem pe Ioanis Binietoglu, care lucrează într-un ONG și împreună cu noi și la nivel european încercăm să îi împingem pe politicieni să implementeze legislația de care avem nevoie ca mai departe companiile să poată facă reducerile, să implementeze reducerile de metan de care avem nevoie și îl avem pe Adrian Staicu, reprezentantul unei companii petroliere care implementează aceste, adică pune la punct programe și tehnologia necesară ca să reducă emisiile de metan. Deci, din punctul ăsta de vedere, avem, în afară de partea politică, avem tot lanțul valorii, ca să zic așa. Deci, asta a fost ideea și, în orice caz, oamenii de aici sunt în top în domeniul lor. Deci, să-i ascultăm pe ei.
Pentru că, de fapt, asta era și ideea că toate deciziile politice și politicile ar trebui să fie elaborate pe date științifice, da? Pe expertiză științifică.
Care ne lipsește de multe ori.
La noi nu se prea... Adică nu e asta reflexul, să elaborezi o politică bazându-te pe expertiză științifică.
Și de multe ori îmi pare rău că se ajunge aici, trebuie să pârâm companiile care nu-și fac treaba ca să reușim să le facem să se miște mai repede.
Ok, discuția o să fie în engleză, pentru că oaspeții noștri vorbesc engleză. Dacă cumva vreți detalii, vreți lămuriri în limba română, o putem face. Adrian s-a oferit voluntar să ne facă traducerea. Bun, so, let's go. Alba, I think it will be very interesting to start with this picture, yes? Okay, this is the first satellite who is trying to catch, to discover, to measure methane, yes?
Well, thanks for the introduction. This is MethaneSat, is the satellite that is going to be launched next year by the Environmental Defense Fund, the organization that I work on. It's not the first satellite that measures methane. There are already some of them out there in the space that are measuring methane. But MethaneSat is going to do two different things. Let's put it two that I think can be highlighted. One is that it's going to measure things that the other two satellites cannot measure. Not things, because all of them measure methane, but it's going to measure methane in such a way that other satellites cannot do. So it's going to cover 80% of oil and gas production. And it's going to look at these areas that you see, these squares around the Earth where oil and gas is being produced and where we know that methane is being emitted. So it's going to have this global coverage every 3 or 4 days. And the satellites that are right there right now cannot do that because they can only look at very specific points, but single sources of methane. And MethaneSat is going to look at wider areas that are important or that are relevant for policymakers to fill this gap of knowledge that we have. And another thing that MethaneSat is going to do is to provide this data ready to be used by policymakers. So right now the satellites that are up there measuring are very science research oriented. So scientists are the ones that use this data for their own knowledge. And what the organization is going to do is to put this data out there so everybody can use it. So the public knows where methane is being emitted, so policymakers know who is emitting this methane and who they need to go to tell them, okay, you should cut your emissions. So this is the main difference of MethaneSat compared to the other satellites that are out there right now.
Okay. We will go into details, and you will show us some very nice movies, short movies. But Ioannis, first of all, tell us a little bit about this remote sensing, Clean Air Task Force.
Yes,
What is this doing?
So Clean Air Task Force is a non-profit organization. It is based in the United States, but now operates globally. And the goal of Clean Air Task Force is to tackle the impacts of climate change. We do this by promoting different technologies. From geothermal to nuclear fission or whatever other ideas, whatever option there is available. We believe that every option that is available to tackle climate change, we should try and should invest in it and try to see if it is an option. But the quickest and fastest way to do is to reduce methane, and this is why we have a very big program on trying to reduce methane globally. And the way we try to do it is use the data that are available. We don't plan to launch our own satellite, but we are trying to use the satellite data and other measurement techniques to highlight the problem to all policymakers, educate policymakers of how to use it, and also try to force companies to use this data and take action and reduce methane worldwide.
From what you know till now, do you think policymakers are aware about how important this issue is? Is this an issue already, methane?
3 years ago or 4 years ago, it was not an issue at all. I think now it is becoming a much more important issue.
Why?
I think because people realize that taking action only on CO2, only on carbon dioxide is not enough, and we don't have enough time to cut carbon dioxide emissions, so we need to cut methane, because methane goes out of the atmosphere very fast. So if we stop methane emissions, we are going to drop the temperature of the planet within our lifetime. So this is the only way we can do that. So 2 years ago, 150 nations signed a declaration, which is called the Global Methane Pledge, which they promised that they will reduce 30% of their emissions very soon. The problem is they have no idea what their emissions are, so they can promise whatever they want, but if we don't know where to start and we don't know where they end, then this doesn't make any sense. So our goal here, and this is why measurements are very important, is first of all to make the invisible problem, to make it visible so everybody knows there is a problem, but then also quantify it so we know where we are, and then we can also plan the next steps to move forward.
To have the dimension, the scale, yes, of this issue. Adrian Staicu is running a private company who is trying to reduce the ecological footprint when we extract, transport and store, yes? In the oil industry.
Partly correct. So PXP Group, it's at the base, it's an oil and gas operator, an international oil and gas operator, implementing a lot of decarbonization solutions on our own operations. And starting last year, we create a new division assisting our colleagues from the industry to decarbonize their operations.
But this is important because, and it's also interesting, so we are looking at this methane, issue, when we extract, when we transport things in oil industry, and also when we store them, yes?
That's correct.
So these are sources
Yes.
of methane?
Yes, that's correct. Those are potential sources of methane if we're discussing about oil and gas industry.
Mm-hmm.
Because on oil and gas industry, there is a lot of focus across the globe due to the fact that the technology exists and can be implemented. Although, if we are looking at a large scale, it's roughly 19% of total emissions. So 19% of total emissions of methane across the globe are coming from oil and gas, rest farming, agriculture, but the challenge is that on farming or agriculture, there is not available a technology, or at least as far as I know, already proven that can be applied. So that's why it's the focus on the oil and gas industry.
But the industry was aware about this thing, yes? Or
Yes.
more or less?
Yes, so regarding the overall emissions on methane, we can look on economical aspects instead of, as our colleague said, instead of losing the valuable hydrocarbons, to put them on metering stations because they are valuable. And on the other hand, it's the environmental footprint and the already proven technology. So this is the key in the end.
Speaking about technology, what kind of technologies are available now?
So for each type of potential emission sources, each type of installation, there is a technology. However, this needs to be calculated, adapted, engineered. Later on, you'll see some examples of these technologies that can be applied, and also I've put few case studies of what already has been implemented.
Okay, let's show them now, or yeah. It's better to discuss having so.
Okay, so I was not preparing many slides, just just a picture, but we can discuss to that. So across the value chain in oil and gas business, we're discussing about wells, pipelines, compressor station, gas treatment plants, and CO2 process facilities, which is again related to the processing of the hydrocarbons. For most, actually for all of the components, you can see that the vapor recovery units can be applied. So what means this vapor recovery unit? It's a system who basically capture the vapor in an installation, put them in a processing or in a compressor, and then can be either used for generating electricity if there is no possibility to feed that gas into a pipeline, or if we have a pipeline around the facilities, can be easily defeated in a transportation system.
So if you are speaking about, if you are talking about vapors, that means that no matter how to say, well, it's sealed, everything, there are still some vapors?
Could be. It's depending on the installation type.
How old it is?
How old it is. Design can be issue of design.
It has to be designed dedicated to this methane?
Not quite, because in Romania at least, the oil and gas business is running since 160 years.
Yeah. But they didn't think about methane, I think.
Evaporation. In the past, no. So the methane focus is since indeed 3 years. 2 years ago, 2.5 years ago, European Commission was releasing the methane strategy. Then they create the first draft of a regulation. Now it's still under debate since last year, December, if I'm not mistaken, December 22. Still on hold. So and the regulation itself, it's describing the measurements, the detection, it's imposing a repair, and then it's part of the operator of the engineering departments to look, to analyze, to design or upgrade the processes.
Mm-hmm. Okay. Alba, you had some pictures about spots in Romania?
Yeah. So we can talk about Romeo. So Romeo was a campaign that was done during, I think, 2019 and 2020 and 21, if I'm not mistaken, around there.
So Romeo Part 1,
yeah, there was
21, and Romeo Part 2, 22. But here I'm curious, was not any satellite involved, no?
No, there were no satellites involved. So here you can see the measurement. So these are parts of Romania where there is oil and gas being...
the red?
Yeah, the red and the green as well.
Okay.
So there are different parts or different sections of the value chain as Andrew was pointing. So then this happened basically because one of the things you need to know all the emissions is to have multiple instruments, so multiple measurements. So there is no one measurement type of one technology that's going to see all the emissions, because you have small components that emit methane, but you also have bigger leaks, and you can also imagine how an oil and gas production site is very big, so you cannot go with a camera everywhere. So the way this campaign was set, it was using multiple types of measurements. So they were using cameras, but also they were using drones, and they were using an aircraft as well. So there were no satellites involved, because satellites, the ones that are right now up there, they cannot measure the amount of methane or at the resolution that this oil and gas or these methane emissions are happening. So that's why there were no satellites involved. But then I think, this is a nice picture as well that shows you the different type of equipment that actually emits methane. That you might have seen this type of equipment, right? If you
These are still in function, all these things, or they are
in
closed?
function. Yeah, these ones are in function, so they
work.
And correct me if I'm wrong, but I think all the parts that were measured in Romania are functioning.
That's correct.
Okay.
Although we know that there are a lot of abandoned oil and gas wells in Romania, but these were functioning operators, and they were. So as I said, so they were driving many, or they were using many type of measurements. So here you can see a truck, because I was saying, so this type of facility or this type of equipment might be emitting methane, but it can be emitting methane from many parts. So you might not see where is it, and then your strategy is to just drive around and see where the methane is escaping, or where is which part of the equipment is leaking, and then use another type of instrument to actually look at a finer scale and see here, for example, you can see how they are using a camera, because if you want to go in these pipes, you cannot drive around, right? So you need to actually you go around with the camera to see actually which part of the pipe are emitting methane.
But this has to be a special camera, yes?
Yeah, so it's an infrared.
Okay.
It's an infrared camera, and I think maybe we have an example of. Now we can look at an example of how this camera, because one of the things of methane is that it's invisible to the eye, so you cannot see it. So that's why we say many times making the invisible visible when we talk about methane measurements. And then you see that guy in the picture that he's basically with a backpack that has a measuring device, and he's just walking around and measuring methane. So you can actually go on a hike and measure methane. So maybe I will put a picture that I think it's nice. This one, but first I would say maybe some results of the Romeo campaign, because I think that's also important.
Sure.
Because when we measure, we want to have some conclusions on what happened or what this measurement told us. And what the Romeo campaign saw is that there was, in 2019, if I'm not mistaken, there were 120 kilotons of methane being wasted to the atmosphere. And to put it into something that we can sense, this was enough to power 1 million homes for 1 year. And this will be equivalent to all the homes in Bucharest, in the city that we are.
So it's not only that the effect is, damaging, yes? There is a damaging effect. There is also a loss.
Yeah, it's a waste. It's a waste, and I think it was mentioned also.
Mm-hmm.
It's something, and I think that's why these last years it has bring more attention, because oil and gas companies have learned that if they fix their leaks, they can actually sell.
Mm-hmm.
They can put this gas into the market, and they will make money. So it's also a win-win situation for everyone.
Just one, because you touch on an interesting thing. Is the market aware of this? That this can be a business?
Totally aware, yes.
Okay.
But once again, it's depending on the complexity. It's depending on the installation type, of the field specific, country specific. So there are many factors that can be approached and debated on this.
Okay.
Yeah, the International Energy Agency estimates that 75% of methane emissions can be reduced at no net cost. So that's a big number. But maybe, Johannes, you can talk about this, because this was a campaign that was run by Clean Air Task Force, and I think it's really, I'm still amazed every time that I see these pictures.
Maybe to explain a little bit these pictures, because they are different.
Yes, so this is part of our effort to show an invisible problem to policymakers. And to do that, we go with the specialized camera that Alba mentioned before, which is an infrared camera that is looking at a specific wavelength of light, so a specific type of light that is absorbed only by methane and nothing else. And so on the top, you see normal pictures of some oil and gas infrastructure. And as you see, you can see nothing coming out of these pipes, and you think probably they're not working. But if you try to look them at the infrared spectrum, you suddenly see that there is something, which is methane, coming out of these pipes very clearly.
So these are the same pipes, but in infrared.
Yes. So these are the same pipes at the same exact moment, but you can clearly see with different colors here. The colors doesn't matter. I mean, here they're just to highlight that there is something different. You can very clearly see plumes of methane coming out of these pipes. And so suddenly something which is not a problem, you see it as a problem. And this is very powerful, and we have seen to have a big effect on policymakers and the public and also companies. They say, oh, actually there is a problem here, we need to do something about it.
Okay, and how big is the impact? I mean, are we truly aware about this problem?
For me, it's like people are waking up from a very deep sleep. Some of the people are waking faster. Some are still half asleep. But the thing is that we are now in a cycle that we have more technologies, we can see more methane, then we become more aware, and then we build more technologies, and we see more, and we are now at this ramp-up stage. We suddenly realize that it's a problem. Suddenly we realize it's everywhere, and now we don't know when this will stop. Every time we see again, everywhere we see methane, and I think people are realizing more and more how big an opportunity is and also how big a problem it is.
But when you say people, you are thinking about researchers, scientists, policymakers, public?
I think everybody. First of all, it's policymakers, it's scientists, it's also the public is becoming more and more aware of the issue.
You have experience in this remote sensing kind of technology, yes, to look at methane in Romania, Italy, Greece. Can you make a comparison? Which of these countries are more aware? I think you should stay there and keep it up.
So I would say that there is a big difference. Romania is a big producer of oil and gas. So Romania has a lot of more emissions, and also has a bigger history of oil and gas production than the other countries, so it has older infrastructure.
But not so much awareness about this.
There is some awareness lately, but this is everywhere. There is no one which is far ahead. Maybe the US, they are a little bit ahead of everybody else, but everybody else is waking up at the same time.
We have a skeptic person here. Adrian does not agree with you.
No, I'll say that in terms of methane emissions and overall emissions, Nordic countries of Europe, Norway, they are way ahead.
Norway has a lot of oil to exploit.
You know, it's also a mixture, because if you think about Norway, we had earlier the short discussion. So 10 of their producing wells are equivalent of 100 or 200 in Romania, because they have larger fields. But also the political aspects. As an example, in Norway, they have banned the flaring, you know, burning the associated gas on a flare stack since 20 years ago.
And why don't we do this?
Now with this regulation, looks like the routine flaring will be banned. However, also will be kept not on a daily basis, so not a routine, but will be just for emergencies. So this is also a safety issue. So again, it's the mixture between specific and technologies.
Yeah, I think also Norway, in the case of Norway or countries that have a lot of oil and gas facilities offshore, so on the ocean, for safety issues, they are more strict on the controls that they have on emissions and on the whole process of extracting gas. So I think that also makes it that they have less emissions because of this. For this reason, so I think, in the case of Romania, is just also we need to think Europe brings most of the gas from outside, so also that makes it to blame Romania for all the emissions that the EU from the gas that we all as a Europe consume. It's not fair, because we are exporting a lot of we're bringing gas from many other countries that are polluting, and we don't know what happens in those countries, right, or in where the oil and gas is producing. So it's just fair to say, but as we were mentioning or talking about before, it's also, we don't want to blame anyone. And I think this is important to highlight. We don't want to pinpoint anyone. We just want to all together, scientists, organizations, companies, we just need to be aware of the problem, because that's the only way that you can reduce your emissions. The only way to reduce them is to know where they are. And the only way to know where they are is to measure them and to know how much you are emitting, right? So that's...
Yeah, I was not thinking about blaming somebody, but I was thinking that Romania, like it is written here, has a long tradition, yes, in the oil and gas production. So you could have expected that with this tradition, with this experience, to come also the awareness of this problem, or is not proportionally? I mean...
Here I'll say that the graph needs to be a little bit corrected, because we're discussing about quantities.
Okay.
But this should be correlated with the production volumes. So the best way to assess the comparison between the countries will be on methane intensity and not on quantities.
Okay, this becomes very, very specific.
So yeah, just to explain a little bit more.
Yeah.
So Romania, it's producing whatever.
A lot.
A lot. Okay. And it's having their emissions. Spain, they have a smaller quantity of emissions because they produce way below than ours. So that's why the best assessment will be to look at the intensity rather than
the
quantity.
Okay. But you touched a very interesting thing, maybe. So there are offshore, yes, production, exploitation and production. Is there a difference on the nature of methane that is released if you exploit on the land and offshore? No?
No.
The same?
It's the same. It's just methane that it's been escaped from the gas that you are taking from the surface. So it's the same. It doesn't have any difference.
Okay.
As for example, you have a different signature on the methane if it's emitted from agriculture. So the molecule itself have a different, let's say, surname or family name that you can trace back to which is. But in the case of offshore and onshore, it's just the same. But it's true, as I said, because of security reasons, offshore emissions are not less, but because when it happens offshore, it's typically a very big emission. But because of safety, it's probably less of an issue than it's onshore. It's also less than onshore. It's mostly produced on offshore.
Okay, what pictures do we have?
Let me check what else do we have. Yeah, so this is also, well, maybe we can talk about, I don't know what you think, it's interesting, maybe the different technologies. So we were discussing this at the beginning, right? I will start with this. When you asked me what satellites were out there measuring methane, and I mentioned there are two types of satellites that are right there, right in the space now, measuring methane. We have Tropomi up in the picture, and you see that Tropomi can see this very wide swath, so this big area of the Earth. And it has a pixel resolution of 7 kilometers. And then you have, on the other side, you have YeGSat, which is what we call point imagers or local, the one below. And you see that there's very small squares that it can measure, so I can maybe point to it. So you see these very small squares. So this satellite measures these small squares, and then we have Tropomi that measures these very wide that area. It covers a lot of area. So then MethaneSat, what it's going to do is something in between. So it's going to measure a wider areas than YeGSat, but with better resolution than Tropomi. And I think the next picture that I had.
But this doesn't mean that the traditional technologies, the ground technologies, will be abandoned.
No.
Remote sensing, for example, will not be. Yeah, Ioannis?
No.
No, not at all. Because each technology gives you a very different view of what is going on. Satellites will give you the huge emissions, and they can monitor in places where we cannot go elsewhere, but they will not give you the exact location, they will not give you small emissions, they will not give you day-to-day emissions so much. So what we need to build is technologies, a system of systems. So as a big system that uses all the technologies together in a harmonized way, so we can get the information we want at the scale we want all the time.
So this information can be, they are actually complementary, yes? There is a complementarity between these things.
Yes.
You put this together and you get a big picture.
Yes.
A complete picture.
Oh, and this is an example of such a system of systems, such a synergy of satellites. So we see on the left, let's say on the background, an image from Tropomi, the first satellite, the one which is
here. This
above.
one or the green one?
This one here is a methane concentration as seen by Tropomi, which is this satellite which looks at large areas but with very coarse resolution. So you see there are, with red colors, you see there are some methane being emitted from somewhere there, but you cannot really understand where it comes from. So then you call, you see this information, you call another satellite, GAG-SAT for example, and then this zooms in at your source. It zooms in just in this very small area, in this 10 kilometers by 10 kilometers. Here, you zoom here and you see exactly the plume in very high resolution, and if the projector had also high resolution, you would see that this is a landfill emitting all this methane. So this is an example of system of systems, what scientists call a tip and cue. So one satellite tips and the other follows and sees the detail. So with such type of combinations, we can use the best of both worlds and guide our mitigation efforts.
Very interesting.
Yeah, and eventually, so this is an example from a landfill, but if this will be an oil and gas a facility, for example, then you will go with a smaller device of the type of that the ones that they use to pinpoint the exact location, because this can the GAG-SAT can tell you exactly in which part it's. So imagine if this will be an oil and gas field, right? Imagine that this is a bigger area, and then GAG-SAT will tell you in which part of your oil and gas field the emission is happening, and then you will go there, and because this is maybe 100 meters or 500 meters, you will go there with a smaller device to measure the actual emission. So this is a little bit of this. You need all all the technology together to get to the final value of the emissions that are.
Adrian, maybe you can tell us a little bit more about how these things are working on the field?
Yes, so the idea is that once a satellite is detecting a methane emission, then we have a big problem, because it's related with the detection limit. So now methane SAT will be able to detect from...
So the area source, so in 1 kilometer square...
in terms of quantity.
Yeah, so in 1 kilometer square, it will be 5 kilograms per hour, the detection limit. So it's going to be, but it's still 1 kilometer square, so 1 by 1. So you can imagine how much equipment you can have in a 1 by 1 kilometer square, right? So
I was just asking because if we're coming back with the methane regulation, the upcoming methane regulation is describing detection limits of 1 gram per hour.
Is it possible? Is it realistic or?
It's realistic. You can detect, but it's making sense.
You can detect, but can you avoid this?
Yeah, so 1 gram per hour will
it's
transpose
nothing.
in.
I mean,
yeah. So. Yeah, indeed. So that's why all this work, researches, technologies, satellites, detections, engineering, calculation, economical aspects needs to be taken into consideration, because we have a focus on methane emissions, but let's not put it on the over-exaggerating.
Yes, and there is another thing. I think Toma or somebody mentioned that the contribution of methane from oil and gas production and these things, it's 19%?
19%, correct.
19.
19,
Yeah?
yes, yes.
So the rest is other sources.
Rest it's a mixture between landfills, agriculture and farming.
Yeah, okay.
I guess the farming is the biggest.
Yeah, the problem or why, and I think I have a nice picture of.
Then maybe policymakers will think, okay, does it work to make some efforts to deal with this? Is this really an issue?
Yeah, so I think the why the focus is on oil and gas, it's because, and I think you mentioned it before, no? So we know how to fix the methane leaks. We still don't know how to, for example, a landfill. Imagine to reduce the landfill emissions. There are things that can be done at the landfill level, but it's mostly waste that we all generate, right? So that's
so we cannot fix farming.
Yeah, and farming is the same problem.
Yeah.
So farming means that we all need to. I mean, there will be a way. I mean, there is technology being developed and being investigated to reduce methane emissions from agriculture for sure. To capture these emissions and to convert it into energy, but the technology is still not mature enough. So that's why the focus is on oil and gas, because it's clear how this can be actually fixed. So I think next phase we will talk in a few years, and we will be talking on how this technology of agriculture and landfills will be more mature and will be there already to be used, but that's not the case yet.
Yannis?
Yeah, just also to ask that the oil and gas has and if you compare with agriculture and waste, you have a very different market. So the oil and gas, you have very big companies with a lot of money.
It's richer, yeah.
And also less companies. I mean, maybe you have 3,000 companies that if you can convince them or push them to do something, they will solve their problem and they can do it in the next 5 years.
But they will solve their problem. They will not solve the problem.
Yes, but they will put us in a trajectory. We shouldn't focus only on oil and gas. We should focus on everything. But oil and gas can do it in the next 5 years. And then if you want to tackle waste, in waste you have double problem, because you have all the waste which are already in landfills, which are emitting, and then we have all the new waste that we are going to produce. So we need our new waste needs to be not to send to the landfill, and also fix the previous landfills. And then if you go to cows, which is the third biggest problem, then you don't need to convince 3,000 companies, but you need to convince
the
millions
farmers.
of small farmers in India and China.
In the Netherlands, they will protest, they will block the streets, the highways.
I mean, this is not a problem. I mean, they have, it is the cow, if you want to solve all the cow problem, all the cow methane, then it's a much bigger logistic problem. So we need to solve all. We start from oil and gas, go to waste, go to the cows.
So we started with oil and gas because we know how to do it. It's smaller, yes. It's easier to deal with this.
And they have the money.
And they have
not him, but somebody has the money.
Yeah, they have the money. So we know who has the money. But the question is, the technologies, the methods can be extrapolated to the other fields?
Not really.
The instruments, well, in the end.
The measurement technologies, yes. So as we invest a lot for oil and gas measurements, then we will also get measurements for cows and rice and oil landfills. The solutions are completely different. And so this is a big challenge.
Adrian, you wanted to add something?
Yes, so the industry somehow assist this reduction. So now it's developing more and more the biomethane.
Biomethane?
Yes.
Okay.
So now we are looking into the options to create biomethane from farming and from agriculture.
Ah, okay.
Yeah.
And how you will do this?
So, as an example, the waste from agriculture, whatever it's fermented somehow, then through different projects. Okay, you cannot use as pure biomethane, but blended with the natural gas can be easily used. Anyway, if I'm not mistaken, even nowadays, according with some regulation, in the fossil fuels, we need to have the bio part, I don't know, 10% or whatever. So even nowadays in the diesel or in the gasoline, we have some bio diesel or bio gasoline.
So why is that picture there with that waste?
Yes,
It is a source of
yeah, those
methane?
are the landfills. Yeah,
Yeah, you're right.
yeah.
Of course.
Those are where we put the waste, and if this so fermentation is happening, and then methane is being emitted. So if you don't typically seal them, because there is a way
Yeah.
to seal them, and if you don't seal them properly, then it's being methane is being released.
So another reason not to drop everything this way.
Yeah, so if we're discussing about landfills, it's, I don't know, I believe that half of the problem can be sorted out with the proper recyclation or collecting properly.
Yeah. Okay. Let's show some other pictures and use those guys who are keeping the screen there.
Yeah.
Don't move. You are moving the images.
Yeah, so maybe I can show this, because this is also nice, an example of so something that we were talking before about the other measurements that we can use. So you see here an example from a drone, and this is again from the Romeo campaign. So you see there the drone, that below the drone there is the device that is measuring methane, and you have this flying around basically of the oil and gas facility. And then you also have aircrafts. We also use aircraft with a sensor below the aircraft to measure methane. And here's another footage as well where you can see. So this is similar to what we were discussing before, how you make it visible, no? So you have
this
on
is
the
before
left,
them?
so
Okay.
not before. So,
No?
so it's the same. It's at the same time. So it's the same footage. But this is on the left is how you will see it with your eye. So with naked eye, that you don't see the methane, and then on the right. You see the cloud of methane that is being emitted. So you see this
Measured by the drone or by the
so
plane?
it's
By the
this is
sensor?
an aircraft. Yeah, so this is I believe it's an aircraft or a drone. Now I'm not completely sure, but basically
Helicopter. Helicopter.
Yeah. Okay. Yeah.
You can see the shadow.
Okay. Yeah. Let's see. So basically, one is within a camera that it's an infrared camera that makes it visible, and the other one is just as a naked eye. So it's very again, if you don't see this, you wouldn't, you wouldn't think that there is methane being emitted. And when you have these cameras or these measurement devices, you basically see it. So it's.
But these things should be very useful for, I don't know, health policies. I mean, you can take care of those areas.
Yeah, I think one of the, and I think Johannes was mentioning it briefly before. So one of the problems that we have right now that to fly over these places, you need to ask for permission.
Yeah,
right.
definitely.
So one of the nice things of the satellite is that you don't need to ask for permission, and we can think that we all, as Europeans, are very civilized, no? And from the Romeo campaign, you go to the government, you talk to them. If you go, there was a landfill in Madrid, they went to the government, they talked to the government. Look what we have found out.
If they belong to the government, if they belong to private companies.
Yeah, but then also always the government can play a role there. But yeah, that's. So you can go and talk to people, but imagine if you are in Libya or if you are in Algeria, where there is a lot of emissions from oil and gas. It's not that you can take the phone and call someone, right? So for us for permissions, and then you will have the satellite that will actually see the emissions in those places where we cannot access by foot, no? That you don't get the permission. So that's also something very nice that the satellite will bring to all this discussion.
Okay.
Let's see what else we have. So, so this is something, but this is what we can say that this is an extreme event of methane emissions. So this is an accident that happened in
here or
no. This is no. So this is in the U.S. So
okay.
this is in Ohio. So there was an accident. There was a big blowout of one of the extraction places, and then basically you can see, and this is a plume from Tropomi, from the satellite where we were talking before. That is the one that sees the coarser resolution. So the worst of the satellites right now. So you see still how big the emission was, because you still can see the plume right there. But this is a very extreme case. We still see. So this is a plume seen from Tropomi, and I think Johannes, you put this nice picture, no? These are all the plumes of this type that that Tropomi satellite has seen. That has seen worldwide. So
And what is the legend? The colors?
So the colors are well,
Johannes?
you can.
Yeah. So this is, I will present, but it's her work actually. But okay, I can talk about it. So this is a global map for within 1 year. So for 1 year, the satellite was measuring, and every day they automatically detected where they saw these huge plumes. And each color represents a different sector. So red are oil and gas, and blue, red is gas, blue is oil, yellow are landfills or cities. And so you can see that there are methane emissions everywhere, and each comes from a different source. For example, in India, they have big problems with landfills. And this is the main issue. In China, they have huge problems with coal, and also in Australia. Russia emits a lot from gas and mainly from the pipelines. And the US, of course, has problems with everything.
According to the dimension.
Purple blocks. You said
yeah.
that they are unclassified. What's there? There is a huge tropical area there.
I think it is wetlands, but Alba can explain.
So the purple areas, you say it right. So it's the tropical areas. So in this study we say that it was unclassified because wetlands have not a problem, but typically these wetlands are really next to other sources. So it could also be agriculture, or in the case of even Africa, in some places it could also be oil and gas production. But you can, because
It's
because it's a lot of methane. So I think mostly from wetlands, but it cannot distinguish. So the problem with Tropomi is that it's a very big. The pixel size is very big, so you cannot distinguish. So imagine if you have this 7x7 square. Many things are happening in this 7x7 square. It's not a wetland, so you cannot distinguish, and that's why you cannot classify into what it is.
Do they have a huge gas production there in equatorial Africa?
Yeah, it could be. You want to talk about?
Also, yes. Can I
Yeah, sure.
try to answer this question?
I told you should have stayed here.
All right. I was in Colombia a few years ago doing a documentary, and we ended up in some marshlands. So exactly these wetlands that you're talking about. And we found out that those marshlands have been dried for palm oil production. So when you dry marshlands in tropical areas, also that could also be that could also represent a very big event and source, because a lot of methane gets evacuated all at once when you dry them. There's a lot of methane. There's a lot of organic matter that decomposes and becomes methane on the bottom of these marshlands. And I found out for myself when I was swimming to find my drone in one of them, and I was stepping on leaves, and basically a lot of methane came bubbling up to the surface.
Definitely, but when you are drying a wetland, you are actually stopping methane production, not releasing it.
But you are releasing it. So what has it been produced so far that is on the bottom of these, so it's underwater mainly, gets released. It is trapped, yes. But also there is a lot of research that is happening right now to determine if marshlands in the equatorial regions are actually net producers of methane or they sequester methane.
Yeah.
So that's the thing, we don't know yet.
But you don't see similar blobs in South America, for instance?
Anywhere,
or in Asia?
actually.
And this is a good question, because more general question, and this is why I like this map, because this map shows us what the satellite can see, but it's very hard to picture what we cannot see. So, for example, before even we go to wetlands, you see Nigeria. Nigeria has very big oil and gas production, and you see no emissions. You go in West Africa, nothing.
Nothing.
Nothing in only in some parts of Australia,
yeah.
Europe, England, nothing. Brazil, south of Argentina, they have very big production with a lot of emissions. Nothing
in
again.
Nordic countries.
Canada.
Nothing.
Hmm?
Canada, yes.
Norway, yeah.
Yeah.
Norway, Sweden,
we
Finland.
don't talk about Norway. But all these are limitations of the satellite. The satellite cannot see there. Maybe because there are clouds, maybe because there are mountains, maybe because there is too much wind, maybe because there is too low wind. You don't know.
Always. I mean, they didn't see anything, no matter of when they...
In Western Africa, for example, there are these very large periods of the West African monsoon, so there is always cloud cover for months and months. They don't see anything. I know in South Argentina, when they tried satellite, not this one, they have problems. There is too much wind all the time, so the methane gets very, diffused very fast. But Alba knows much better what the problems of the problem.
I mean, also one thing that we need to when we look at this map is that, so you see the smallest circle is 101 tons per hour. That's a lot of methane, like a lot. So the sensitivity or the detection limit of the satellite is really high, so you won't see. I mean, it won't see the small stuff. So and that's why methane sat is going to bring another dimension, because methane sat is going to see the small stuff. But here you see it in the title is so what it's called super emitters. So this means like very big methane events, as the explosion that I was showing. So these are really, and I think the explosion in Ohio was, if I don't remember badly, it was 50 tons per hour, and that was already, that's already in the limit of what the satellite can see. So that's why I mean that these are really big emissions, but the smallest stuff won't appear. I mean, you can look at Romania, Romania here. There are landfills we were discussing before, right? So there are landfills, but the oil and gas is not captured by Tropomi here, the oil and gas from Romania. So from satellite, so this is related to what you were mentioning, asking before, if it's possible to differentiate between one methane or from one source or the other. So these are called isotopes. So it's called isotopes. So methane, depending if it's emitted by a biogenic source, so if it's emitted by a cow, for example, or if it's emitted by fossil fuels, have an isotopic signature. So it has a different carbon footprint.
And this is another important aspect, because you have to differentiate
between the sources. And that's also something that with Tropomi is very difficult to do when you are looking at the small emissions. So the satellites, for now, there is no technology from satellites so there is ground technology or remote technology that can look at this isotopic signature, but not from satellites. But one of the things and that's why it's also nice methane sat, is that it's going to look at, so the footprint that methane sat has, it's going to be able to differentiate between sources, no? So it's going to, with this resolution, you will be able to say, okay, this is oil and gas, or this is something else.
Because you know what's there.
Yeah, because it's a smaller resolution or finer resolution, so that will give you also the chance to separate between sectors, which is really important, because right now it's a little bit with this with the satellite is different. It's difficult to attribute emissions to different sectors.
Okay, but at this very moment, can you say which part contributes more, natural sources or
so anthropogenic sources? I think it's 40%. I would say. So it's not the most one.
From this 19% that it's
no. So you have methane from natural sources, that is 60%, and then you have anthropogenic. 60 to 40. Okay. Anthropogenic, 40, and natural 60, more or less. Correct me. I think it's not 50-50. It's a little bit more for natural, and then from this 40%, and then you have this 20% that it's oil and gas, and then agriculture and landfills that are getting the most share of it.
Okay.
Sorry,
Yeah, just one. Okay.
Wanted to refine your definition of natural. Does it include agriculture and animal husbandry or not?
No, so natural will mean wetlands, for example. So nothing that has to do with man-made. So agriculture will be anthropogenic,
yeah.
because we are the ones that have done this. So
Okay, so anthropogenic includes oil and gas emissions, landfills, and also agricultures and
yeah.
animals.
yeah,
Okay, thank
that's
you.
correct.
Okay, other questions? No, not yet? Okay, let's try to wrap up. So, let's imagine that we are trying to write some recommendations for policymakers. What would be your point? What is the most urgent thing from each one's point of view? Yanis.
I would say that any action, the most important thing would be that any action has to be based on science and on data. So we need a lot of measurements, good quality measurements, and then we can prioritize what is the action is. Of course, in the meantime, until we get the perfect data, we can start to solve the problems that we know, oil and gas and waste. But then we need to have measurements and guide our understanding through this.
Okay. Adrian,
Yes,
what would you say?
so I guess that should start with a national program, with something on paper, with a guideline for any specific area. If we're discussing about oil and gas, landfills, agriculture, and so on.
But
Starting from that, we should look to the low-hanging fruits, what can be done immediately, at low cost, and will have the highest impact.
And what will be this?
So
Immediately with...
Immediately, okay, will be the oil and gas.
Okay.
But in the oil and gas business, as this regulation is describing that 1 gram per hour, I don't think it's making any big impact if we are focusing on all these small parts, rather than go first on a risk-based approach and take care of the super emitters or the big emissions that we have across the value chain.
What is the bigger emitters? What are the bigger emitters?
So the biggest emissions are coming for the entire value chain in the industry. I cannot say that it's coming from a specific compressor station or from a wellhead or from whatever across the value chain, because it's depending on the installation type and mainly the age of the installation. So the idea will be, at least in my opinion, to look on the big emissions that can be mitigated, and then to start slowly improve to look at new processes, upgrading installations, because some of them can be, emissions can be fixed even with a tightening round. So
there is an interesting word, inventory. Do we know at the national level now where are the sources of methane? What are the most polluting?
We have the inventory. We don't know the most polluting. We can look because we have the inventory. We have all the infrastructure can be accessed, and then we can look to to researches. We can look to because even myself, I've been involved a few years ago in a project. So we had some research to identify the behavior of equipment based on the installation type. So we can look to science, we can look to articles, we can look to international guidelines, to standards, to our inventory, and then we can define somehow, but this will be at theoretical level.
Yeah, because on the practical level, standards means that you have to behave the same way. Yes?
Yes.
So you have to change technology, you have to change the infrastructure.
In some cases,
in
yes.
Some cases.
In some cases, yes.
Okay. Alba? And then Mihai, please think about answering this question.
Yes, I think it looked like, or I can resonate with Johannes, so I think we are from the same background, so there is a lot of common sense to this. So I think data gives you power, and science gives you power. So I will definitely tell the policymakers to embrace this data. I don't know, this data flow that we're going to see, including with satellites, and that we need all this information to know what is going on. You were briefly mentioning it. Now our inventories are based on very old emission factors, so on very numbers that were estimated years ago. So we need to keep up with the new things that we know, with the new science that has tell us that this is not the way to go. So embrace this and don't be afraid, because I think we are always afraid to the new things, right? To the new rules, but eventually this will become operational, and it will become part of everyone's daily life. So I think we all need to work together, and I think this is also something very important, that we operators, scientists, organizations, the community, that we all work together to solve this problem, because basically our future life depends on solving these problems.
Okay, and I am the policymaker, yes, and you come with all these things. You have the measurements, you have the data, you know what to do. Where should I start from? What is the starting point of this?
Well, I think oil and gas, it's something to start.
I was looking at you. Okay.
Because it's what we know, and it's what is already out there. I mean, I cannot give you a solution for the cow problem.
Okay,
I cannot give you a solution for anything else. I mean, we have a solution for oil and gas, and we know that this is, and fossil fuels are going to, it's our big problem, not only for methane but also for CO2. So
okay, oil industry.
Yes, so oil industry, it's already acting, not at the proper speed, but it's already acting. So the idea is that it's the focus on detection, on measurements, and even in the legislation, I saw many governments, and programs at country level, but I don't see guidelines for mitigation.
Yeah,
so
mitigation is.
We're discussing about, okay, we measure that wellhead, we know that it's an emission.
So what?
So what?
Yeah, Dionis.
On this, there are two approaches on how to go. There are two types of regulation. One is what we could call a prescriptive standard. So we can tell them, change all your old this type of equipment with a newer type of equipment, and you have to do it.
On your own costs?
On your own cost, of course, yes. And some countries give some subsidies, there are some other incentives, but the idea is we give them instructions what to do. This is clear, we know it will have effect, but this needs to be updated when new technology comes, and maybe they have better ideas and they cannot implement them. Because we tell them what to do. A different approach is to give them targets. We don't care how you do it. We just want you not to emit, and you have to emit less than this percentage of what you produce. This is more open to innovation, more open to, they give them freedom to do whatever they want and do their thing much better and have some competition between them. But then the question is, how do we measure all these emissions? And it creates a lot of requirement in monitoring and seeing that there is done progress. So there is currently this debate. I don't know which one will win. Maybe a little bit of both is the way forward.
I think the second approach is better from my understanding, because it gives you again room enough to innovate. On the other hand, they cannot say, okay, this is too costly for us. We can adapt our costs. Maybe, I don't know.
But I want to say something, and I think I said this earlier, and there are studies that show that most of the emissions, and it might be that a small operator, that's not the case for them, but on a global scale, most of these emissions can be abated at no net cost. And this is something to keep in mind, because the gas that you don't emit is gas that you're going to sell. And this is something to...
okay.
Yeah.
And then double these measures with selling, with the business part.
Yeah,
of this.
yeah. So
yes. Okay.
because if you stop emit into the atmosphere, it will keep on going to your value chain, and eventually it will reach the houses of everyone. And so,
and who should sell this gas? The oil industry?
yeah, the oil. Yeah, so imagine that you are a gas operator and you have a leak and you fix it. So the one that the gas that you are not emitting, it will go. No, so it's.
Indeed, totally agree. Actually, some of the abatements can be profitable.
Okay.
As an example, even for us as a company, we are investing our own money in projects because the payback will be from the hydrocarbons saved.
Great. Mihai.
What question am I answering?
I forgot.
There's a little bit of everything, I guess. What I would tell a policymaker and what I'm telling policymakers is, well, if you're just trying to replace coal with gas, for example, because Romania is on a phase-out strategy until 2030, so we're phasing out coal. But if the emissions intensity from gas is more than 3%, then gas is polluting just as much as coal. So there's no point in replacing it if we don't do anything about these emissions that we've been talking about. You know, there are a lot of things to say and there are a lot of approaches, but I always tell policymakers to first of all listen to the science, because this is what we need to base our policy on. So listen to these guys. Get connected at international level, because Romania is one of the countries that is not part of any voluntary mechanisms, schemes, or anything. It didn't even sign the Global Methane Pledge that 130 countries or more have signed, and we're still trying to. It's a symbolic. It's a symbolic thing that Romania can do.
And why didn't we sign it?
Because Romania wanted to have it wanted to have a study to see how much methane we can reduce by 2030, and the study has been blocked at the Ministry of Agriculture for 2 years now.
Okay.
We've been told. So, and we've been told that a lot of countries have signed without, without having an analysis done to know what they can do by 2030. Just to remind everyone, the Global Methane Pledge is reducing collectively, so all the countries among themselves, they reduce 30% of their methane emissions by 2030, with 2020 starting time. So in 10 years, we reduced 30% of our methane emissions, and this is a global effort. So again, I come back to what I'm saying to Romanian policymakers is get connected. There's all this know-how. And also, this is the same thing that I'm telling oil and gas companies. Get connected. Because the know-how is out there. The technology, like Adrian was saying, is out there for 15, 20 years. There's a lot of things that you can do if you start measuring your emissions. And there are already studies out there, like the Romeo study that resulted from the campaign in 2019, that tells us we're already underestimating our emissions. And by underestimating our emissions, we're losing close to, the oil companies in Romania are losing 90 million euros a year. But it's also a question of energy security, right? So now with the war, we've been having problems with, everybody's invocating energy security. That's why we have the offshore oil and gas projects, and that's why Romania wants to be a regional energy provider for Moldova. It will be
according to the ministry.
Exactly. We keep saying this, but we lack in investments in our electricity grid. We lack in the investments. Germany is installing 1 gigawatt of renewable energy. I think every month or so. Anyway, it's a lot that we keep lagging behind. We don't have the legislation, we don't have the regulations for offshore wind energy, for example, where we know it provides a lot of, it provides almost the same efficiency as the old power plants, you know, with coal or gas, right? Up to 60% because the wind is blowing. So
But-
just to come back to methane, it's a lot of the stuff that we haven't been doing at all. So Romania can catch up very fast to other countries by just tapping in to the knowledge that is out there.
Okay, but all these pledges, all these measurements, all these plans were, how to say, all these decisions that we will reduce it were taken also considering the social impact of these things, because I'm thinking about the Netherlands again, yes, and about their source of methane, which is farming, cows. Yes, it was. There were huge protests last year in the Netherlands because the government is trying to reduce, yes, the number of cows that each farm can have because of one of the reasons being this, to reduce the methane.
Yeah, and that's why
footprint.
agriculture is the last one. So that's why we're talking about the low-hanging fruits, which is oil
But
and
meanwhile,
gas.
did we do social impact studies of these things?
No, because first we need to catch up on the science to see how much, for example, emissions are in the agricultural sector.
A lot, we know.
Yeah, a lot. But also, there's a lot of research that is working to see how, we can, first of all, if we find any additives to reduce the methane that is emitted by cows, yes, that's one approach. And the most difficult approach, and this is, we all have to think about this, so not just the ones that are producing the meat and the dairy, it's about reducing meat consumption. This is one of the very big things we can do to reduce methane in the agricultural sector, is reduce meat consumption. And it's very, very hard to speak about this because
Absolutely. It will also affect the
Well, it will also. I'm speaking as a man with a high cholesterol right now, so basically, it's also thinking about our diet and the way things have been going, that we can solve some of these challenges that lie ahead of us.
This is too far away. I mean, the diet issues will be solved after we will solve all these.
But talking about the social impact, look at what happened last year. We were all extremely afraid that we were going to be able to switch on our heaters at home in winter. And, you know, everybody, I mean, I was in the Netherlands in the winter and I was at home with my friends and I was freezing because they didn't want to switch. It's like, no, don't switch it on. No, maybe we will run out or maybe the bill is going to be so...
So we're talking about costs to society. And the climate change also brings with itself costs to society. So there's a social cost of methane as well that we need to count into that price.
That's why I'm saying that we need to count all these social costs.
Exactly. But it's
in parallel with all these things.
It's very hard for us to take all of this in. There's been a lot of talk about our personal carbon footprint.
Mm-hmm.
This was invented by an oil company.
Yeah.
Just so you know. So a lot of people don't know this, and then a lot of companies have been putting like plastic consumption and all the stuff that we consume on the consumer, and it's because it's very profitable for companies. So it's time with policy making and the science behind it, like the biggest change, because that's where the money is, that's where the profits have been. The biggest change is it should be incurred, and the social responsibility, because we have all this corporate social responsibility nowadays, should be incurred by companies as well. So it's not only us, but we're in the decade and we're in the times where we have been lagging behind our actions on climate change, so we need to pick up the pace really fast, and everybody basically needs to do it. So when we think about societal costs, it's very hard to put everything and for people to understand, people that have nothing to do with what we're talking about, to understand that they need to move on this in one way or another. But the costs are upon us, so to speak, all of us.
Yeah.
And we're incurring the costs in our everyday lives. And what Alba was saying earlier is very true. I have friends in Belgium. They were, I visited them last year or in 2021, and they were afraid. It was 17 degrees, 16 degrees. Like, put a sweater on. I'm not turning on the gas because it's gonna cost me a lot.
Okay. Questions? No? Still no?
Is the debate phase already? Or still
We are trying. No. You can ask if you want.
Yeah, I'm curious about
Take
that.
them.
I'm curious about that pump jack. How much methane is emitted by such an installation, if any?
We
Have you
haven't-
measured?
Thank you indeed, because you're right. So we're discussing about an oil well out there. So the methane impact will be just from associated gas, which is not that much during the pumping. So in this type of installation, it's an oil well. Once again, the methane, it's very limited or nothing.
Yes, because that's the kind of oil that doesn't contain much gas.
That's correct.
Yeah.
Again, it's depending on the area, on the reservoir we have.
We have a lot of these in Romania.
Yes. So those, when you see such of equipment, that it's an oil well.
Okay.
Well, I can say we visited one field with the OGI camera in 2021, and we looked at 50 oil wells, 52, and 50 were leaking out of 52. So it's not much, as you said.
Which type of motor they had?
It was that type of well. I cannot tell the difference.
No, you should see the difference, because the optical gas imaging is not seeing just methane.
Oh no, I know, but I was with it's not myself,
Mhm.
but I was with an accredited person who can use the camera. So you could tell methane from, and then what we filmed was further analyzed. So we could eventually determine it was methane that was coming out.
There is another question.
You do some spectral analysis to distinguish it from other greenhouse gases that absorb in infrared?
No?
Yeah, you would do a spectral analysis. That's the way it
Mhm.
works. You know,
Okay.
with the satellite. Yeah, that's the technology behind most of some of the technology. So not with the cameras, because that's an infrared.
Yeah, I meant the camera. The satellite was obvious, at least for me.
Yeah.
You wanted to ask something?
Hi everyone. I have a question for Alba regarding to the new satellite. You told us at the beginning that the current data of the satellites is made for science, and you plan to put it somehow publical. How's the plan? You want to represent it in mapping or just data?
Yeah, so that's a very good question. The measurement, how it works is that first you measure a concentration in the atmosphere, so that's not actually telling you how much is being emitted, and then you need a model that relates this concentration to how much is being emitted. So that's the first distinction. Maybe I can... So this is a concentration map. You see it. You don't see it because it's blurry, but this is in ppb. So this is the concentration of methane in the atmosphere. So this is not telling you how much is being emitted, but it's how much is in the atmosphere.
How much is, I mean, in what, how do you measure how much?
Yeah, so that's why you need to convert this into, so you need a model. So basically you need an atmospheric model that relates this concentration with the wind conditions and with the, so it's a little bit complicated, and that's the part that methane sat is going to jump, because right now tropomy data is just concentrations, and scientists that know how to convert this, they do this conversion. So methane sat, the team will basically provide already emission rates, so how much methane is escaping into the atmosphere. So this is already a big step because there is no such a thing right now that is being available. And MethaneSat will put this out there in a website, so it will be a web portal where you can actually go, enter there, and you can go in a map, so it will be shown as a map. Maybe I have, let me, so basically you will have a map similar to this, so these are the squares, 200 by 200 kilometer that MethaneSat will target around the Earth, and then you will be able to each of these small squares of 1 by 1 kilometer to click and see how much methane is being emitted. So that will be, let's say, the public access to the data, where you as a citizen or anyone as a citizen can actually go to the website, look in all these places that it will be measuring. So this is some of the targets that MethaneSat will look. So you will basically press one of these targets and see this detailed information on emissions. Then there will be other ways to access the data. Imagine that you are an operator that actually wants to have their data in their own system or something, so there will be also possibilities of doing that. But this is basically, as somebody that is a non-expert, to have direct access to emission rates of how much methane is being emitted in all these areas.
So we have two big hopes for methane measurements. One is MethaneSat, and the other is Carbon Mapper. Carbon Mapper is a spin-off from NASA, which they partnered with some private companies in California state, and they are building also their own satellites, which these will look more like GHGSat. They are more zoom in to specific facilities. And they already have, even though they don't have the satellite, their own satellites yet, they will also launch them a little bit after MethaneSat, I think. They already have their own data portal, which they analyze data from other instruments which are on space. So if you go at data.carbonmapper.org, you will already find a map with a lot of emissions around the world. You can already see them.
I only saw so far land-based emissions. How about ocean-based natural emissions? Can they be detected, or aren't they accounted for, or are they very small? Sorry for.
So overseas, the satellites we have now have problems because the satellites work by looking at the reflected light, and the oceans are dark for the light. But if you go under specific conditions, so if you look at the reflection of the sun, at what we call the sun glint, then you can see methane emissions there. But again, not the natural emissions, but you can see oil and gas emissions from offshore wells under specific alignment. You need to align your satellite with the sun to see the reflection, and then you can make the inversion. And actually, yesterday it was published. It was released a paper from GHGSat demonstrating this capability and showing very, very encouraging results.
I see. Okay, thank you.
Okay, so if there last one.
You said that these satellites cannot see methane unless they manage to get into special configuration in relationship with the sun, for instance, and so on. Or if there are not enough cloud cover to mask the emissions and so on. So how could you actually evaluate each territory emissions of methane in order to be able to compute how much 30% reduction, how large a 30% reduction should be, in order to see if the methane pledge is fulfilled or not?
So I think you need to combine multiple measurements, and also it depends on the country. If you are in a country where satellites cannot see anything, then you need to use other techniques. If you are in a region where, for example, in Romania, you have a lot of troponin measurements, and then you can combine these with atmospheric models and calculate overall emissions of the country. But then you need to use other measurements to try to pinpoint exactly what the source is. So I think it is an iterative process of using all available information and coming with your best guess.
And is there any, I don't know how to say it, a validated model or generally accepted, agreed model to check the level of methane emissions?
I mean, there are well-known techniques, but again, Alba knows better.
Because unless we have a generally agreed on model, you will definitely find some countries saying, well, this is not correct, our emissions are far lower, and or your emissions are far higher than you say, and so on. And there will be a lot of disagreements.
So you are posing a very interesting question in the table, which has many things to analyze, but I will try to be brief. So one thing is the science part of the measurements and how is if it has been validated, and so the technology out there is already quite mature in that sense, and there are there has been validation of comparing different type of instruments that measure the same thing to see if they agree, if they give you the same number, and then you can more or less say that if two different things measure the same thing, then we agree that they might be doing it right. So that on one side, and the same with the models. So there are ways to validate the models, how they, the results that they provide. So then on one thing. The other thing is that how this can be, for example, we'll go with methane SAT, and I will say, okay, in this area there are these emissions. So a company can say, no, I don't trust you. And I think that's where the companies need to use measurements, alternative measurements, independent measurements to actually, so I'm fine, I'm methane SAT, and I'm telling you you are emitting this much, and if you don't agree, then just show it to me. I think it's fair that you don't trust me, but then you need to show me with data, and I think it's a little bit what I was trying to say before. It's like with data gives you power. So if you show to me with data, with good quality measurements that you are emitting less, then I will trust you and I will look a problem somewhere else.
Okay, so thank you very much. If there is no other question, Mihai, you want to ask something?
No.
Okay. Thank you very much for being here, for showing all these things, for sharing all these things. It's a very complex topic, issue, problem, so we might meet next year also to discuss about this, but it is very, very interesting anyway. So, and this is a real problem that we have to deal with. Ok. Mulțumesc foarte mult pentru că ați venit și seara asta. Vă invităm și mâine, nu aici la Humanitas, la Cismigiu, unde o să vorbim despre, cum Institutul de Fizică și Inginerie Nucleară poate să salveze cărțile folosind iradierea și așa mai departe. E un proiect foarte interesant cu Biblioteca Națională, o să vedeți. Și duminică, nu? Duminica, Toma, la ora 5, tot la Humanitas, la Cismigiu, vorbim despre noua carte care se cheamă Imun, vaccinul și așa mai departe.
Și în general despre importanța vaccinării în prevenirea a tone de probleme
Încercăm
majore.
să-i convingem pe cei care știu sigur că vaccinarea nu este utilă.
Mai ales pe un pământ plat.
Da. Mulțumim foarte mult. Thank you again. Ok.